Okay, let us move to the next question. We have discussed up to question number 26 and now we will discuss further question. I am going to discuss question from question number 28. I am going to skip question number 27 because that's an easy question, so you can do it yourself. So we will going to discuss a new concept in question number 28. Okay, the concept is, you might have studied this concept in physics. The concept is Archimedes principle. The concept that we will going to study is the Archimedes principle. Now, what is Archimedes principle? Try to understand it with the help of an example. Let us say this is a bucket which is filled with water. Okay, this bucket is filled with water till the top. Okay, it is completely filled up to its brim. Okay, the boundary. So this bucket is full of water. Okay, till the top. Now what happens if I drop an iron ball? Okay, this is an iron ball. If I drop this iron ball in this bucket, okay, if I drop this iron ball in this bucket, what will happen? Try to imagine there is a bucket which is full of water up to its brim and you drop an iron ball inside that bucket. The only thing that will happen is this iron ball will sink. Okay, this iron ball will sink and will stay at the bottom of this bucket, like somewhere here. Now, is this the only thing that will going to happen? Obviously not. Why? Because since the bucket was full previously, the bucket was completely full and I have dropped this iron ball inside this bucket, so definitely some amount of water will flow out. Okay, due to addition of this iron ball inside this bucket, some amount of water will flow out. Now, what amount of water will flow out? Is it dependent on the iron ball or is it dependent on something else? So what we did is, we repeated the experiment. We repeated the experiment using a steel ball. Okay, using a steel ball of same dimension. Okay, what I did is, I repeated this experiment with a steel ball of same dimension and I dropped this ball inside this bucket. Now what will happen? Again, this steel ball will sink inside this bucket, okay, and it will stay at the bottom of this bucket like this. In this case also, some of the water will flow out of the bucket. Okay, try to understand. What I did is, first I used an iron ball, I dropped it inside a bucket, it will sink and some amount of water will flow out because of the addition of this iron ball. Then what happened? I removed this iron ball, I repeated the experiment one more time, but this time I used a steel ball, and when I drop this steel ball, this will also deposit at the bottom, it will also sink and again some water will flow out. Now, what peculiar thing I observed in this experiment is that since the size of iron ball and the size of steel ball were same, okay, their size, their volume were same. So the amount of water that flown out when I done this experiment with iron ball is same as the amount of water that will flow out when this experiment is repeated with steel ball. Okay, मैंने दो अलग मटेरियल का सेम साइज का बॉल लिया और दोनों को ही एक जैसे बकेट्स में डाला एंड आई ऑब्जर्व जो अमाउंट ऑफ वाटर फ्लो होता है, जो ओवरफ्लो हो जाता है, जो पानी उसमें से छलक जाता है, दैट वाटर इज ऑफ इक्वल वॉल्यूम. ओके, एंड दिस इज व्हाट द आर्किमिडीज प्रिंसिपल. रिमेंबर, Archimedes principle is a very broad concept, but we are not going to deal in that concept because that's a topic of physics. Our main concern will be how that Archimedes principle is used in mathematics to solve questions of surface areas and volumes. Okay, our only target, our only discussion will be limited to the concept, the application of Archimedes principle to solve the questions of this topic. So what I told you is, I observed that even I am using the different materials but of the same size, the identical size, the amount of water that will flow out or amount of water that will be displaced is same. Okay. So the general observation that we will have is, when this bucket is full up to this brim, and if I drop this steel ball, there will be some amount of water will flow out. Okay, ऐसा आर्किमेडिस ने कहा, ऐसा आर्किमेडिस ने ऑब्जर्व किया, ऐसा प्रैक्टिकली उन्होंने इसको करके देखा और ऑब्जर्व किया कि जब मैं एक आयरन का बॉल या एक स्टील का बॉल पानी में डालता हूं तो जितना पानी उस बकेट से फ्लो होता है वह पानी उतना ही है जितना कि उस ऑब्जेक्ट का वॉल्यूम है. ओके, आर्किमेडिस ने क्या कहा कि जो ऑब्जेक्ट का वॉल्यूम है उतना ही अमाउंट ऑफ वाटर इस बकेट में से फ्लो होगा. व्हाई? बिकॉज जिस जगह पर इस वक्त ये आयरन या स्टील का बॉल है, इस जगह पर पहले क्या था? इस जगह पर पहले पानी था, लेकिन क्योंकि मैंने इसमें आयरन या स्टील का बॉल डाल दिया, सो आयरन या स्टील के बॉल ने यहां पर अपनी जगह कैसे बनाई? हाउ इट हैपेंड कि ये जो स्टील का बॉल है ये बकेट में नीचे जाता गया और फाइनली इस बेस पे जाके डिपॉजिट हो गया. ऐसा क्यों हुआ? क्या ऐसा अगर यहाँ पर वाटर की जगह कोई और लिक्विड होता तब भी होता? क्या वाटर की जगह आयरन होता तब भी होता? नहीं, ये सिर्फ वाटर में हो रहा है, ये सिर्फ लिक्विड्स में हो रहा है. तो कंडीशन क्या देखी जा रही है? दैट दिस आयरन बॉल या स्टील बॉल, ये स्टील बॉल पानी को डिस्प्लेस करती हुई, उसको चीरती हुई पानी के अंदर जाती है. ओके, व्हाट इज हैपनिंग? दिस iron ball or steel ball displaces the water inside this bucket to deposit at the bottom. Okay, now क्या ये इस बेस को, इस बकेट के बेस को भी ब्रेक कर सकती है? नो, ऑब्वियसली नॉट. दैट्स व्हाई ये स्टील का बॉल यहाँ पर डिपॉजिट हो गया. बट इसने क्या करा? इसने जैसे ही हमने इस आयरन बॉल को या स्टील बॉल को इस वाटर में डाला, इट स्टार्टेड डिस्प्लेसिंग द वाटर. ओके, इट डिस्प्लेस द वाटर. नाउ अब क्योंकि ये बकेट पूरा टॉप तक फिल था, तो अगर वाटर को डिस्प्लेस किया जा रहा है, सो वेयर शुड दैट वाटर गो? दैट वाटर विल ऑब्वियसली फ्लो आउट ऑफ द बकेट. ओके, वह वाटर इस बकेट से बाहर की तरफ फ्लो हो जाएगा. सो आर्किमेडिस सेड द अमाउंट ऑफ वाटर that will flow out of bucket the amount of water that will flow out of the bucket is equal to the volume of object that displaced water. Okay, this is a small analysis, a small conclusion of Archimedes principle that is required for this topic. Okay, remember I am again saying Archimedes principle is a very broad concept. We do not need to deal the complete concept. Our only task is limited to this concept. Okay, try to remember this concept, try to understand. What I have written is the amount of water that will flow out of the bucket is equal to the volume of object displaced, volume of object that displaced water. It means अगर इस बकेट में मैं इस तरह का एक स्टील बॉल ड्रॉप करता हूं, तब द अमाउंट ऑफ वाटर that will flow out, जितना volume of water that will flow out होगा, that volume of water will be equal to the volume of steel ball. Okay, तो इस steel ball के volume के जितना water इस bucket से बाहर की तरफ flow हो जाएगा. Okay, so for example अगर इस steel ball का volume है let us say 100 centimeter cube, then what will happen? 100 centimeter cube of water will flow out of this bucket. Now 100 centimeter cube of water means 100 ml of water. Okay, because we use the unit ml, that is milliliters or liters for the water, and we use centimeter cube or meter cube for the steel ball. So remember, the quantity is same, that is the volume, only the unit is interchanged. So what I say is, if this is of 100 centimeter cube, then 100 centimeter cube of water will flow out of the bucket, or 100 centimeter cube is equivalent to 100 milliliters. Why? Because 1 centimeter cube is equals to 1 milliliters. So this is the concept that we need to use. So now, based on this concept, let us solve question number 28. I am skipping the question 27, it's very easy question. So let us solve question number 28. Question number 28 says, a vessel is in the form of an inverted cone. Its height is 8 centimeters and the radius of its top, which is open, is 5 centimeters. It is filled with water up to the brim. Okay, it means it is filled with water up to the top, up to its top. When lead shots, each of which is a sphere of radius 0.5 centimeters, are dropped into the vessel, 1/4 of the water flows out. Find the number of lead shots dropped in the vessel. Okay, so let us try to visualize this question. It says that there is a vessel. So first let us draw a vessel. Question number 28. Now what kind of vessel is this? This is a conical vessel, okay, which is inverted cone. Okay, it's an inverted cone. The vessel is in the shape of inverted cone. So let us say this is the vessel. This is the vessel. Okay, it's an inverted cone, and this vessel is filled with water up to its brim. Okay, that is up to the top. It means if it is filled up to the brim, it means I cannot add a single drop of water more inside this vessel. If I try to add one more drop of water inside this vessel, the water will flow out because it is filled up to its maximum capacity. Okay, now it says that the height of this cone, height of this conical vessel is 8 centimeters. Okay, and the radius of its top, what is top? This is the top. Okay, this top is open and the radius of this top is 5 centimeters. This is the radius of the top. Now what happens is, someone started throwing lead shots. Lead shot means there are some spherical lead balls. Okay, these are some spherical balls which are made up of lead. Okay, and the radius of these balls are 0.5 centimeters. These are spherical in shape. Okay, it's like a ball, small ball. So I started throwing these lead balls inside this vessel. Now what will happen? Just the same condition that we have here in the Archimedes principle. If I start throwing this lead ball, if I drop a single lead ball inside this bucket in this vessel, what will happen? The equivalent amount of water will flow out. Let us say the volume of this small lead ball is V. Then what will happen if I drop one ball, one such sphere in this vessel? If I drop one such ball in this vessel, V amount of water will flow out, because this is what the Archimedes says, the amount of water that will flow out of the bucket will be equal to the volume of the object that displays the water. Because if I drop this sphere inside this vessel, it will start displacing water, and how much amount of water it will displace? It will displace the water which is equivalent to its volume. So this V amount of water will flow out if one sphere is dropped inside this bucket. If I drop one more sphere, then again V amount of water will flow out. If I drop one more sphere, then again one more V amount of water will flow out. So in this manner I started dropping such lead balls in this vessel, and what happened is that 1/4 amount of water, okay, 1/4 amount of water contained in this vessel is flown out. So what is the total water that is contained inside this vessel? Amount of water available. How much amount of water is available? It is 1/3 pi r square h, 1/3 pi r is radius is 5 square into h is 8. So this much amount of water is available with me. Now if I start dropping this lead spheres, lead balls inside this vessel, 1/4 amount of water will flow out. So amount of water that will flow out will be equals to 1/4 of the total volume which is available, 1/4 of the 1/3 pi 5 square into 8. Okay, this much amount of the water will flow out. Now try to understand, if this much amount of water is flowing out from this vessel, then what should be the volume of lead balls that is placed inside this vessel? इतना वॉल्यूम ऑफ वाटर को बाहर निकालने के लिए मुझे इतने ही वॉल्यूम की लीड बॉल्स की जरूरत पड़ेगी. ओके, ट्राई टू अंडरस्टैंड दिस कॉन्सेप्ट. मुझे इतना वॉल्यूम ऑफ वाटर बाहर निकालना है तो कितना लीड बॉल्स चाहिएगा. दिस अकॉर्डिंग टू आर्किमिडीज प्रिंसिपल, आई नीड द लीड बॉल्स whose total volume, whose cumulative volume is this much. Okay, 1/4 of 1/3 pi into 5 square into 8. So let us say, let x number of lead balls are required to, let x number of lead balls are required to displace 1/4 water. Okay, let x number of lead balls. So what is the volume of this x number of lead balls? Volume of x number of lead balls will be equals to x into v. Now what is v? V is the volume of one lead ball. I can see the radius of one lead ball is given as 0.5. So this v is equals to, what is the volume of a sphere? It is 4/3 pi r cube. So 0.5 into 0.5 into 0.5, that is 0.5 cube. So this is the value of v, that is the volume of one sphere. And how much spheres I require? I require x spheres. Okay, so therefore total volume that is required is x into v. Now according to Archimedes principle, now as I told you, जितना वॉल्यूम ऑफ वाटर हमें बाहर निकालना है उतने ही वॉल्यूम के लीड बॉल्स हमें चाहिएंगे. हेयर हमने लिखा x इंटू वी, x नंबर ऑफ लीड बॉल्स चाहिए और कितना वॉल्यूम बाहर करना है, इतना. सो दैट्स व्हाई आई कैन राइट 1/4 ऑफ 1/3 ऑफ pi r square into h is equals to x times v. V is what? It is 4/3 pi into 0.5 cube. Okay, 4 upon 3 into pi into 0.5 cube. So here मैं इस 3 और 3 को cancel कर सकता हूँ. This 5 and 5 will also get cancelled, and this 4 2s are 8. Okay, so this will be 2 into 25 upon 4 into 5 into 5 into 5, or this is what? This is 0.5, that is half. So this half can be shifted here, and it will become 8. Okay, 1 upon 2 cube. So this is equals to x. So just solve this. This will give you 4 2s are 8, 2 2s are 4, and 4 into 25. So you will get x is equals to 100. So what I can see is I need 100 such lead shots to remove or to displace 1/4 of the water available in this vessel. Okay, so this is the question. This is just a simple application of Archimedes principle that we have studied. You just need to apply this and solve the question. Okay, so 100 balls I need. So this is the solution for question number 28. Okay, very interesting question. Okay, you can note this, then we will solve next. Okay, let us now solve question number 29. Question number 29 says, a solid consisting of a right circular cone of height 120 centimeters and radius 60 centimeters standing on a hemisphere of radius 60 centimeters is placed upright in a right circular cylinder, okay, full of water such that it touches the bottom of the cylinder. Find the volume of the water left in the cylinder if the radius of the cylinder is 60 centimeters and the height of the cylinder is 180 centimeters. Okay, so let us try to visualize this question. First, the very important thing in this chapter is to draw the perfect diagram. So it says a solid consisting of a right circular cone of height. So definitely there is a conical shaped solid. So first I will draw a conical shaped solid like this. This is a conical shaped solid. Okay, the height of this solid is given as 120 centimeters. Okay, and the radius of this solid, the radius of the base of this solid, this base radius is given as 60 centimeters, and further it says it is standing on a hemisphere of radius 60 centimeters. It means the base of this conical solid is a hemispherical base and the radius of this base is 60 centimeters. Okay, let us say this is the base, which is a hemisphere, and this hemisphere also has the same radius as the radius of cone. Okay, now further what I did is I put this conical shaped solid, okay, this solid figure inside a cylinder. Okay, and there is a cylinder like this. This is, let us say, the cylinder. The height of this cylinder is 180 centimeters. This is the height of the cylinder, and the radius of the cylinder is given as 60 centimeters. Now this cylinder is full of water up to its brim. It is completely filled with water. Okay, now what I did is I took this solid figure and try to insert this particular solid figure inside this solid figure, okay, inside this cylinder. And when I kept this solid figure inside this cylinder, the final situation becomes something like this. something like this. Okay, so this is the situation that I will finally get when I keep this solid inside this cylinder. So because it says that if this solid figure, this conical shaped with hemispherical base, is placed upright in a right circular cylinder, like this, and finally it touches the bottom of the cylinder, it means it is completely inside the cylinder. Okay, this solid, when it says in the question that this particular figure touches the bottom of this cylinder, I can very easily interpret that it is completely immersed in water. Okay, it is completely immersed. Now what will happen if I put this solid figure inside this cylinder? This solid figure will displace water to make space for itself. Okay, definitely if it want to come inside the water, it has to displace the water. So the amount of water that should be displaced to put this solid figure inside this cylinder must be equal to the volume of this solid figure. Okay, what I want to say is amount of water displaced to put solid figure inside cylinder is equal to what? This amount of water should be equal to, it should be equal to volume of the solid figure. Okay, so definitely what does this mean? This is the concept of Archimedes principle, that volume of solid figure is the amount of water that should be displaced to put inside this solid figure. Now the question asks, find the volume of water left, okay, in the cylinder. So I need to determine the volume of water that is left in the cylinder, and how will I determine this? If I subtract the displaced water from the total water, I will get the volume of water that is left inside the cylinder. So first let us calculate what is the volume of water inside the cylinder before substituting this solid figure. So volume of water before solid figure is kept inside cylinder. Before solid figure is kept inside cylinder, it will be pi into r square, where radius is 60 square, into h is 180 centimeter cube. This is the volume of cylinder. Because the cylinder is filled completely with the water, that's why the amount of water has to be equal to the volume of cylinder. So this is the amount of water that is inside the cylinder when this solid figure is not kept. Now amount of water that will be displaced after keeping solid figure, this amount will be equals to what? It will be the volume of solid figure, as what I have written here. You can see कितना amount of water displace होगा, जितना इस solid figure का volume है उतना पानी displace हो जाएगा. So the amount of water displaced will be equals to volume of this solid figure. Now what is the volume of this solid figure? I can see this solid figure is made up of two parts. First part is this conical and the second part is a hemispherical. So the volume V of this conical part will be 1/3 pi into r square is 60 square into H. What is H? H is 120. Okay, plus volume of this hemisphere. The volume of hemisphere is 2 by 3 pi r cube. What is radius? It is 60. So 2 by 3 pi into 60 cube. This is the volume of water that will be displaced. So I will write this volume here. If I take 60 into pi by 3 as common, so 60 square into pi upon 3, if I take this as common, in bracket I will be left with 120 plus 60. This will be 120 plus 120. So this will be 240. Okay, so this much centimeter cube. So this is the amount of water that I will be left with. Okay, sorry, this is the amount of water that will be displaced, and if you solve this 3 and this 3, 8 times 80, so this is basically 60 pi or pi times 60 square into 80 centimeter cube. So what will be the amount of water left inside the cylinder? इतना तो displace हो गया, इतना total था, so the volume of water or the amount of water left will be equals to what? Amount, initial amount minus volume displaced. Initial amount is pi times 60 square into 180 minus volume displaced is pi times 60 square into 80. So this will give you pi times 60 square into 100 in centimeter cube. And we know a unit, a conversion, that 1 centimeter cube is equals to 1 milliliter. So I can write this volume as pi times 60 square into 100 milliliters. Okay, now you can solve this, it's very easy calculation. So this much is the amount of water that will be left inside this cylinder after placing this solid figure inside the cylinder. Okay, so this is the solution for question number 29. Again a very interesting question. This is also based on the Archimedes concept. Please remember, either in your school exam or in your NTSE exam or in any competitive exam, you will definitely get a question based on Archimedes principle if the question comes from surface areas and volumes. Okay, please remember, this is a very, very important concept. The next concept that is important is Frustum, that we will study in further classes. So first you note this, then we will continue.